Good morning, children. Today we'll be learning about the concept of number system. You might be wondering why the concept of number system is into computers. Right. The roots of computers came from the numbers. Right. Analytical machine, which is also called as mechanical computer, which is also called as mechanical computer. Right, is designed for a calculation purpose, and from analytical machine only the architecture of analytical machine forms the basis for a current computers. In order to understand the computational operations, you need to have a knowledge of number systems. That is why the concept of number system is very important for computer graduates. Now, what is a number system? A number system, which is also called as numeral system, right, is nothing but a way of writing a number. It is nothing but it's a way of writing or representing a number, right? Like your decimal 10, right, is been written as x in Roman and is been written as written in a different format in Tally. So you have various kinds of number system where every number is been represented with different formats using different symbols, right? And ultimately it is nothing we use all these symbols in order to write a number or in order to represent a number, right? There are many number systems existed from our ancient times, like tally, tally symbols, sign value notations, Roman numerals, European number system, right? Various number systems existed from our ancient time. But in our computer science, we'll be focusing on four kinds of number system. They are decimal number system, binary number system, octal number system, and hexadecimal number system. These are the four types of number systems that we'll be focusing on. Now, hexadecimal system in your computers is used to represent the color scheme, right? Like whenever you're using KTurtle or whenever you're using a paintbrush, when you set more colors in order to set, whenever you're setting or selecting a specific color, right? If you look down, you'll be getting a combination of numbers, right? And that combination of numbers is nothing but the mixture of red, green, and blue colors, the ratio of mixture of red, green, and blue colors. And this representation or this mixture of color scheme, or we also call it as a color code, right? In order to represent a particular color code, we'll be using a hexadecimal number system, right? Before hexadecimal number system is into existence, and when it is a time of mainframes, and when computers are of 16-bit addressing mode, right, octal number system is morely used. But once hexadecimal system came into existence, slowly usage of octal number system got reduced. But previously they used to use octal number system in place of a hexadecimal number system, right? And binary number system, as you all know, today's digital computers all use binary number system, right? Or all digital computers or use binary number system in order to store the data or in order to take the inputs from keyboard, right? So system your computers can only understand the binary language. And decimal number system is a number system that is being in our regular usage. The regular in general what we use, or what are the numbers that we are using in regular purpose for presentations, we call it as a decimal number system. Now, the sequence of symbols may represent different numbers in different number systems. As I said, number systems, the formats, the symbols might be changing, but right. So let right. If I take a number 10, I won't call it as a 10 because 10 we call it as we call it in a decimal number system. So if I take a sequence of number 1 and 0, we call it as a 10 in decimal number system. We call it as a 10 in decimal number system. But 1 0 in binary, 1 0 in binary, if you write 1 0 in binary, it is equivalent to 2 in decimal system. It is equivalent to numeral 2 in decimal number system. And if you write 1 0 in octal, it is equivalent to 8 of decimal number system. It is equivalent to 8 of decimal number system. And at the same time, if you write 1 0 in hexadecimal, right, it is equivalent to 16 of decimal number system. So the number is 1 0. If you say it is a decimal number, you call it as a 10, right? If you say binary number, it is equivalent to 2 of decimal, right? This is, and if you say this is an octal number, it is equivalent to 8 of decimal. And if you say it as a hexadecimal system, it becomes 16 equivalent in decimal, right? So the sequence is 1 and 0, but its value changes basing on the number system that you are using. In decimal number systems, we'll be having 10 digits. In decimal number system, we'll be having 10 digits. Those are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the 10 digits that we'll be using in a decimal number system. And after 9, whatever you're writing or whatever the representation you're doing after 9, right, is a combination of these 10 digits, right? Like, let me take an example. For example, let me take a value 28. It is nothing but it's a combination of digits 2 and 8, but in different place, right? So whatever the number you're forming, right, you are going to form with 0 to 9 digits. Now, the base of a number system is nothing but the number of digits that exist in this particular number system forms the base for the number system. Why do we need a base? Suppose if I write a number 10, right? Now, as I said, 10 is 10 in decimal, whereas it is equivalent to 16 of, if you 10 in hexadecimal is equivalent to 16 of decimal. So the value changes with the number system. Now, if you are not representing with the base, and if I simply write 10 and leave, right, then what is the value of it? So in order to understand the value of that particular number, you need to understand to which number system it belongs to, right? So in order to understand to which number it belongs to, we are going to use the concept of base. Now, in decimal, for how many numbers or how many digits are there in decimal? There are 10 digits in decimal. So the base of decimal is 10. So if you are writing any number in a decimal, let me say 45, you have to write as 45 base 10. It indicates 45 is, or 45 is nothing but it is 45 of decimal. 45 is nothing but 45 of decimal. Now, in binary, the name itself indicates binary means 2, right? In binary, you're going to have 2 digits. They are nothing but 0 and 1. So because you have 2 digits, the base for binary will be 2, right? For example, if I'm writing a number 101, this is not 101. If you say it as 101, it goes to decimal again. You have to say 101. 101 base 2 indicates it belongs to binary. If for the same number 101 base 10 if I write, you can say it as 101. But in binary, you can't say it as 101. You have to say it as 101. And base 2 indicates it is going for a binary number system. Now, octal number system starts with 0 and ends with 7. Octal number system starts with 0 and ends at 7. So, because how many digits are there in octal number system? Octal number system had 8 digits. So, the base for this octal number system is 8. Now, if you are representing any number in octal number system, you have to give a base as 8. So now I can't call it as 45. If I say 45, again it goes to a decimal number system. I should say as 45 base 8. I should say as 45 base 8. Right? Now, hexadecimal system consists of 16 digits starting from 0 to 9. As in your decimals you have 0 to 9, similarly in hexadecimal you have 0 to 9. After 9 it goes with symbols of A, B, C, D, E, F. A is equivalent to 10 of decimal, B is equivalent to 11 of decimal, C is equivalent to 12 of decimal, D is equivalent to 13 of decimal, E is equivalent to 14 of decimal, and F is equivalent to 15 of decimal. So 0 to 9 numbers and A to F symbols. We don't call them as a characters, but they are just symbols in order to represent the decimal values of 10, 11, 12, 13, 14 and 15. Right? So after 9 you have, if you want to represent decimal value of 10 in hexadecimal, you have to write A. Right? Now, because you have 10 digits and 5, oh sorry, yes, you have 10 digits and 6 characters. You have 10 digits and 6 characters. So the base forms for this is 16. So you are going to write the number as 45 base 16, which indicates 45 belongs to hexadecimal number system. This is a sample of where I have taken numbers from 0 to 15, a table which is created with various number systems, the 4 number systems starting from 0 to 15, in order to make you understand how it changes from number system to number system. Right? So just go through this table, give a glance to this table. Right? And next we'll be discussing about how we can convert a number from decimal number system to a other number systems.